Hi everyone, this is Prachi Agarwal. Welcome to our channel CodeChef. If you're interested in learning computer science and data structures and want to learn competitive programming, then you've come to the right place because here we post CodeChef problem explanations and conceptual videos on various programming paradigms. So please subscribe to our channel and hit the bell icon for the upcoming updates. Now that you have subscribed, let's get started. Today we'll be solving the problem beautiful pairs, which is a simple problem and belongs to the July lunchtime. Now let us see the problem statement. So in the problem statement we are given that we have a sequence A1 to AN, and then we are supposed to find out that out of that sequence how many beautiful pairs can be formed. Now what is the criteria such that a pair will be known as a beautiful pair? So if you select two elements from this sequence and you want it to be a beautiful pair, then those two elements should satisfy this particular condition. AI and AJ are the two elements that you will select from the sequence that will be given to us. And it is also given here that the division represents real division, so you cannot just take the integer value and be done with it. So you have to consider the decimal value of the division. Now we are supposed to find out that how many beautiful pairs can be formed out of this particular sequence. And it's also given that since the input is large, prefer using fast input methods. So we'll come to that part when we are doing the code. But first let us understand how we'll be able to find out how many beautiful pairs can be formed out of this sequence when we have this kind of condition. So we have three cases. Now, the first case, so before starting with the solution, let us just, declare some things. So this is the condition that we want to make true. And this particular thing is like AI minus AJ is there on both sides of the equation, as you see here also and here also. So we have just taken it into a variable x. So from now onwards, whenever I explain, x will be equal to AI minus AJ. So wherever you see written x, it will be equal to AI minus AJ. Now let us go to our case 1. So the first case will be when AI is greater than AJ. So suppose you select two elements from the array, say 8 and 7. So AI will be equals to 8 and AJ will be equals to 7. This is how AI will be greater than AJ. Now in that case, what will happen when we do AI minus AJ, 8 minus 7 will be equal to 1, and for that matter any number in which AI is greater than AJ will always give a positive value, right? So if we have a positive value and then we try to figure out this equation, so what kind of pairs will satisfy this condition? So all the pairs which have AJ less than AI or AI greater than AJ will satisfy this particular condition, because this x and this x, both of these are same, right? So you can just move your AJ towards this side of the equation and AI towards this side of the equation. This is just like simple cross multiplication that we used to do in the smaller classes. So if you do that, then AJ will come out to be less than AI, or you can say vice versa, AI will be greater than AJ. So for all such elements where AI is greater than AJ, will satisfy our condition, and those kinds of elements will be called a beautiful pair. Now the second condition is, this is case 2, and case 2 represents when AI will be less than AJ. So in the first case we saw AI was greater than AJ and it was forming a beautiful pair. So for this condition it will form a beautiful pair. Now the second condition we will see when AI is less than AJ. So let AI equals to 7 and AJ equals to 8. This is the kind of values that we'll take. Now in this case what will happen, that whenever we do AI minus AJ, it will always be less than 0, or it will always come out to be negative if AI is less than AJ, right? 7 minus 8 is minus 1. So now in this scenario, what will happen, that AJ will always be less than AI because these two values are negative, they will get cancelled, and then we can say that for all those pairs, the beautiful pair will be formed if AI is greater than AJ or AJ is less than AI, that is vice versa. So it means what it means. Why have I told you these two cases? Now, as you saw that in the previous case, I took AI to be 8 and AJ to be 7. And in the next case, I took AI to be 7 and AJ to be 8. So what am I trying to say? That beautiful pair will be formed, like suppose in a sequence, these two elements are present. There is this sequence 1, 2, 3, 4, 7, 8. Suppose this sequence is there, and then you have picked up 7 and 8. So once you picked up 7 and 8 with like AI 7 and AJ 8, and the second time you picked up AI 8 and AJ 7. So both of them are forming beautiful pairs. That is 7 8 will also form a beautiful pair, and 8 7 will also form a beautiful pair. So that is what I'm trying to tell you, that it doesn't have to be that way, that if we've used 7 8 once, then it cannot be used again, because according to the conditions that we have discussed, these pairs will be interchangeable and both of these pairs will form a beautiful pair. Now we will come to the last case, when AI is equals to AJ. So if AI is equals to AJ, it means AI minus AJ will give us 0, right? And if like it is 0, and if we place 0 in this equation, then I mean it doesn't make sense, right? So no beautiful pairs will be formed when this is the case. So guys, after seeing these cases, what we can do is that we have to avoid such kind of pairs where if AI is equals to AJ. So we have to find out that how many such numbers are there which are repeated in the sequence, and then we can find out the final solution. So now from the cases that we have discussed, it has allowed us to understand that if we take any number 8 which is present just once in the entire sequence, then it can be clubbed with all the other numbers of the sequence, and all the pairs that it makes with all the other numbers, all of them will be beautiful pairs. For example, if we pick up 8, then 8 can be clubbed with 3, 6, 3, 1 and 5, all the other numbers of the sequence, and it will form a beautiful pair with each one of them. Similarly, we can say for 6 that if we club 6 with all the other 5 numbers of the sequence, then it will form a beautiful pair. So it means for these kinds of numbers which are just present once in the sequence, we can say that the answer will be n minus count for that particular number. So how you will get this count value? You will get it by doing frequency I. So this is just like a frequency array. So what you can do, that you can either form a map so that you are able to find out that which are those numbers whose count is 1 in the sequence, and which are those numbers whose count is greater than 1, because for that you'll have to think a little bit more, that how they will how you can incorporate them into your solution. So for those numbers which are present just once, this will be the right answer, because like you can see, if you pick up 6, then 6 minus 1 will give you 5. If you pick up 8, then again 6 minus 1 will give you 5. So it will be n minus count. Now, if we talk about those kinds of numbers like 3. So now 3 is present twice in the sequence, and there can be a sequence where the numbers are present even more than twice. So now what do you do in such kind of situations? So now this particular answer will be true, right? N minus count will still be true for those kinds of sequence, also for those kinds of numbers also which are present twice. But you will have to do one additional thing, that is you will have to multiply your answer with the count value. And why is that? Because 3 is present twice and they are present at individual positions. So they are two individual numbers. Now this 3 and this 3 cannot combine with each other. So the pair cannot be 3 and 3. This will not form a beautiful pair. But 3, 8 and 3, 8. 8, 3 and 8, 3. All these four are beautiful pairs and all four will be counted. Why? Because this 3 is supposed to be the one that is there at index 1 and this 3 is supposed to be the one which is there at index 4. So let me rephrase that again. 3, 8 and 8, 3. So here we have used the 3 which is there on position 1. Then again 3, 8 and 8, 3. This 3 we have used which is present at position 4. So you see that whatever be the count of the numbers, that many times we will be using that number to form the pair with all the other numbers, and that is why we are doing into count. So here the solution will be, so if we pick up 3 and the count is 2, so 6 minus 2, that is giving you 4, right? Because you know that this 3 and this 3 will be combined with the other numbers of the sequence, that is the four other numbers of the sequence, that is 8, 6, 1 and 5. Now by multiplying it with 2 again, that is it is giving you 8, you are ensuring that you use this particular 3 with the other four numbers, then you also use this particular 3 with the other four numbers. So you have to use both the elements with the other leftover numbers. So that is how the solution is going to be. So for every number you will count that how many times it is present, and using that count value, if you just calculate this for every number and then accumulate it in one particular variable, then you are going to get your answer. And suppose that for if you do for 8, like you're calculating for 8 and the count is 1, so even if you perform this particular expression for 8, then also it will give you the correct answer, right? It will be 6 minus 1 into 1. So into 1 is not a problem, it will give you the correct answer. So you don't need to put an extra if condition that if your count is greater than 1, only then you will perform this expression, else you will perform this expression. That scenario is not needed at all. So guys, this was the problem explanation. Now we will see the input, output and constraints. So first line of input is the number of test cases, and the first line of each test case has the number of elements that will be there in the sequence, and then in the second line will be given the sequence. The output will be number of beautiful pairs that are given in the sequence, and the constraints, as you see here, they are a bit large. The inputs are a bit large, that is 2 into 10 to the power 5. So that is why it was asked there to use fast IO. And also here I will suggest that you use a data type which has a greater range. So prefer not to use integer data type, because then will create problems. So better use long or long. Then if we talk about the time complexity, so all we are doing is forming the frequency array and then iterating through each of the numbers. So we have a maximum of n elements, right? So the time complexity for this approach will be order of n. Now that we have solved the entire problem, I hope you have understood it well, and if you do, then please do like the video. And now let us go to the code. So I guess that now that we have discussed the entire solution in so much detail, the code will be very simple. So first few lines are just for the inputs, and this you see here, these two lines are used for fast IO. So guys, please remember that this problem is not going to pass without using fast IO, so please do remember that. And I have used LL for long int because the answer can be pretty large, so it's better to use a data type which has a larger range. Now we'll come to the solution. So for the solution I have used a map here. So again, if you will use the frequency array, So the inputs are quite large here. N value is going up to 2 into 10 to the power 5. So instead of using an array which is 2 into 10 to the power 5 long, which will again give you, I think, a time limit exceeded, it's better to use a map. So you can only make those values the keys which are actually there in the sequence. Now we'll just iterate and input every element and then update the count of that element in this frequency map. Now that we have the count of each of the elements that are present in the sequence, it is very easy to calculate our answer. So here this it.second that you see, consider it as the count that I was talking about in the solution. So n minus count into count. This will be the expression that we need to calculate our answer. And for each of the elements, we are calculating it and then accumulating it in this answer variable. So at last, we will just print the answer variable and that's it. We are done with the code. Now, if you have any doubts, then please do post them in the comment section and I'll see you in the next video.